The question says, given that 5 raised to power n plus 3 all over 25 raised to power 2n minus 3 equals 5 raised to power 0, we should find n. Okay, so we look at this equation. Okay, so we see equation involving exponents. Okay, and we refer to this as exponential equation. So how do we solve this type of equation to arrive to the unknown, which is n? Solution. So for 5 raised to power n plus 3 divide 25 raised to power 2n minus 3 equals 5 raised to power 0. And as we know, in our indices, law of indices, when you have anything that has a power at 0 equals 1. So for 10 raised to power 0, we have to be 1. So for anything raised to power 0, any number raised to power 0, it equals 1. So that means when we solve this part of the equation, we are going to have 1 at the end of the day. Okay, for 5 raised to power 0 means 1. So when we take this equation from here, we have 5, so we can put this 25 in index form. Okay, so we can have equal 5s, we can have everything as base 5. So we can write the numerator as 5 raised to power n plus 3 all over. So for 25, we can write as 5 squared, which is 25, but the square will multiply everything we have at the power. So we have this as 2n minus 3 equals 5 raised to power 0. Okay, so we take this from here, we have this as 5 raised to power n plus 3, which is the numerator, all over. So for the denominator, we must use this to distribute this. So we have our base, which is 5. So when we say 2 times 2n, we have this to be 4n. Okay, minus 2 times 3, that gives 6, equals 5 raised to power 0, which is 1. Okay, so what we can work with this, since we have equals to, so that means this can multiply this. Okay, and we equate it to the multiplication of this. So let's try it that way. So when we have 5 raised to power 4n minus 6, okay, so we are multiplying it with 5 raised to power 0, which is this, equals, so this will multiply this. So we have 5 raised to power n plus 3 times 1. Okay, so at this point, since there's times and law of indices multiplying the same base, so we add up the power. So we pick out 5. So we say 4n minus 6 plus 0, okay, equals, so for 1, we can write it as 5 raised to power 0, which is written as 1. Okay, so we add this together, we pick out one of the base, we add the power, n plus 3 plus 0. Okay, so since we have the same base, so we can equate the exponents. So here we have 4n minus 6 plus 0 equals n plus 3 plus 0. Okay, so for 4n minus 6 plus 0, so that's saying 4n minus 6, and for n plus 3 plus 0 is n plus 3. So we can collect the like times from here. Okay, so to do that, we have 4n minus 6 equals n plus 3, and when we collect the like times, we have to bring back this to a side, which is the letter. We have to transfer this to the other side. So we have 4n minus n equals 3. So by the time we add 6 to both sides, we have this as plus 6. So this gives 3n equals 9. So 3 times what gives 9. So we have to divide both sides by 3. Okay, so when we do that, the value of n equals 3. So when we check for n in this equation, okay, we are going to arrive to 1 at the end of the day. So let us try it. So to check, when n is 3, so when we look at this side of the equation, we have 5 raised to power n plus 3 divide, we have this as, so for 25 raised to power 2n minus 3, we represent it with this. Okay, or let's go with this. Okay, which is 5 raised to power 4n minus 6 Okay, so here we have this as 5, for n to be 3, for 3 plus 3 is 6. Okay, and for this we have 5, for n to be 6, for n to be 3, 4 times 3 is 12, 12 minus 6 is 6, so you can see. So when we divide this, 5 raised to the power 6 divided by 5 raised to the power 6, we have 1, which seems to are saying 5 raised to the power 0. So that means the value of n equals 3. Thank you very much.